All right, hello and welcome back. We are wrapping up our probability module. So we've been talking about probability, how to get the counts, conditional probability, where the counts shift. We've been finding odds and things like that. So the last couple of sections that we're going to be getting into, we'll review what the fundamental counting principle was. But then we're going to talk about a very special types of counts that come from situations involving permutations and combinations. So then that will take care of the next two sections. And then in the last section, 11.9, we're going to be finding probabilities again by pulling in combination ideas. So you should also be able to find probabilities involving permutation ideas, but we're going to talk a little bit about how permutations can also be solved using the fundamental counting principle. So those are counts that you've actually been finding already. You sometimes just didn't realize that the scenario you're looking at we call a permutation. All right, so that's what this section is going to be about. So as a reminder, the counting principle, which is how it's referred to in your book, but in other texts it's called the fundamental counting principle, or abbreviated FCP. This is when an experiment is done in stages, and so the total number of outcomes in the experiment can be found by multiplying the number of outcomes on each stage. So for a lot of the questions that we're going to be answering in this particular section, we're not necessarily going to be finding a probability, we're just going to be finding counts of how many ways something can occur. So in this initial example, just to kind of remind you about how this counting principle applies, it says, suppose a password must consist of 4 letters, and we're going to consider upper and lower case the same, and then followed by 2 digits, and then how many passwords are possible if, and then we're going to have different restrictions that come in. So we've got 4 letters, 1, 2, 3, 4, so these are going to be my letter spots, and then 2 digits, 1, 2. How many passwords are possible if you allow any letters and any digits and any spots? Well, at least the letters in the 4 spots, but you're allowing repetition. So you would have 26 letters in each of these spots, 10 digits allowed in the last 2 spots, and then we're going to multiply all of these together, right? That's what the fundamental counting principle says. So the shorthand version for this would be 26 to the 4th power times 10 squared. So if you actually wanted to figure that out, you could plop that in your calculator. You would get 33,177,600 possible passwords. So quite a few. Now what if we don't allow repetitions? That's what's going to be part B. So we still have letter, 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 digit, digit, but once you use up a letter, you can't use it again. So there are 26 letters for the first spot, then there'll be 25 for the second, 24 for the third, and then 23, so then that takes care of my letter spots. Now for the digits, there'll be 10 possible digits for the first spot, and then 9 for that second spot. So this one, multiplying through, so there's not really a shorthand. Well, we're going to learn one in a moment, but for right now there's not going to be, we can't use necessarily exponents for this. You plop all that in your calculator, you're going to get that there are 32,292,000 possible passwords. So still quite a few. Now in the third case, we're going to have the restriction, the first letter must be a vowel. So vowels, so that's A, E, I, O, and U. The last digit cannot be a 0, and repetition is not allowed. Alright, so we're going to have all these sorts of restrictions that we're going to have to take into account. So again, we've got letter, 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 digit, digit. Now the first one has to be a vowel, so there are 5 possible letters for that first spot. Now repetition is not allowed, so at this point in time, once one of those vowels is selected, there's only going to be 25 letters for that second spot, and then the count's going to drop down through the letter spots. Now let's go to the digits. The only restriction we're told is the last digit cannot be a 0. So in terms of this last digit spot, there are going to be 9 possibilities in there, specifically 1 through 9. And then once that digit is selected in this spot right here, there's only going to be 9 possibilities left. because repetition is not allowed. So for this one, throwing all of that in your calculator, multiplying all that out, will give us 5,589,000 possible passwords. Alright, so for the fundamental counting principle, what's going on here is that we're just going to take into account how many stages there are in your experiment. I like to put down blanks for each one of the stages, and then for each stage you're just going to count how many possible outcomes there were at that particular stage, and then you would multiply them all through, and then that gives you the count of how many outcomes are possible.